if we're looking for extrema on an interval, that is, if we're looking for any points where we have a maximum or minimum, a potential maximum or minimum on a graph, then what we're going to be doing is we're looking for what are called critical numbers. Critical numbers are any interior points for which the derivative is equal to zero or the derivative is potentially undefined. Now, there are other points that we want to look at on the graph. So the relative extrema theorem, though, tells us that if we have an internal point, x equals c, if f of x has a relative extrema at x equals c, then x equals c is a critical number. What this says is that any place where we have a maximum or minimum occurring, then we can be sure that it's one of these two conditions. It's either the derivative is equal to zero at that point, or the function is undefined. So if we're looking for any extrema, that is absolute maximums, absolute minimums, or relative maximums or minimums on an interval, then what we should do is the following. First of all, look for any critical numbers interior, that is, any place where the derivative is zero or undefined. Find the value of the function at each of those points. We should also take care to find the value of the function at each of the endpoints and then compare values. So let's go back to an example that we had started before. We had the function f of x equals x squared minus 4x on the interval from 0 to 4. So we're not concerned with what's happening down here at these ends. We're just interested in what's happening in this interval from 0 to 4. And we can see visually some evidence of what's going on right here, but let's talk about the extrema. Well, we know where we get our critical numbers. A critical number for this function f of x occurs at the point x equals 2. So what we should do then is we should look to find the value of f of 2. In this case, f of 2, going to our original function, would be 2 squared minus 4 times 2, which is to say 4 minus 8, that's negative 4. So we know that we're passing through the point 0, negative 4 down here. And the y value is negative. Now we also want to check out what happens at our endpoints. So our endpoints are x equals 0 and x equals 4. So we would certainly want to check those out. In our original function, f of 0 is equal to 0 squared minus 4 times 0. Well, we know what happens right there. That is just simply equal to 0. So 0, 0 is a coordinate point on this graph. And for the function at x equals 4, f of 4 is 4 squared minus 4 times, well, 4. So we also get 0 right here at this point. So the point 4, 0 is another one on this coordinate point. So what would we say? Well, if we're looking for absolute maximum points, we could say that the absolute maximums occur at two places, x equals 0 and x equals 4. We can have more than one of those, right? More than one absolute maximum. Because at those points, right, y is equal to 0. Now we compare that to our other critical number, and we said that we had at x equals 2 a critical number, and that gave us y equals negative 4. So right here, there are no other values of f of x less than that, so we're going to say this is an absolute minimum. And that absolute minimum occurs at x equals 2, right? And we got that because y was equal to negative 4. And there are no other y values on this graph less than that, so we're going to say this is our location of our absolute minimum and absolute maximum. And all of these points fit with our advice right here. So to find our extrema, we look for what happens for any interior points where we get critical numbers, and we find the y value there. We find the values of the function at the endpoints, and then we just simply compare those values together. Okay. there's a piece of advice right here about endpoints of the interval, and we say, well, at the endpoints, that's where we're looking for absolute extrema. But again, we have this term relative extrema, and we're going to want to talk about that here in another piece of our video.